So on page 5, we will be taking a look at this word we've seen before, multiplicity. And it essentially means the same thing. In fact, this first part here is effectively review as we're looking at multiplicity of x-intercepts. So even though this is a rational function, not a polynomial like we've been working with in chapter 3, it is still the case that this multiplicity of the intercepts works identical. This numerator, this p of x, this specifically is where we're going to want to find the zeros of that polynomial, because any value of x that makes the numerator 0 will make the fraction 0, which makes the function 0. So we know that x-intercepts occur when y is 0, right? The x-intercepts are where the function equals 0. Well, the only place a fraction will equal 0 is when the numerator is 0, so that's why we're looking for zeros of p of x. So whatever it takes to do that, again, using methods we've learned throughout chapter 3, factoring, synthetic division, etc. Those are what we want to do to find the zeros of this numerator. And just like they did with polynomial functions, we're looking at the question of whether the multiplicity, which we label c, is an odd number or an even number. And just like before, for odd numbers, we expect the graph to go through the axis. For even numbers, we expect the graph to bounce off the axis at that specific point, right, at that x-intercept value. So like I said, exact same as with polynomials. Now, with asymptotes, with these vertical asymptotes specifically, we already said before, they come from the zeros of q, right? So we know that's where we find them. And as far as their behavior, we can't really use those two words that we use for intercepts. We can't really talk about going through or bouncing off because they aren't points, right? Asymptotes are vertical lines. I'll just bring this first one here. First example, they're vertical lines. So I put the point c comma 0 on here, but remember, that's not a point of our graph. The whole idea is at this value of x, at, in this case, c, that we're saying our graph is doing something. It's going down, going up on both the left and the right, whatever it's happened to be doing, right? And so the question of that asymptote, we can't, again, use going through or bouncing off. So instead, we will refer to the idea of opposite infinities or same infinity for the behavior. And so both these pictures are just really the only two examples, the only two possibilities in terms of opposite infinities. The idea that on one side of this asymptote, you've got your function going down, what we could call to negative infinity, while on the other side, just the other side of this asymptote, if we look at the behavior coming towards it from this right side, it's going up to positive infinity. So opposite infinities, one going down and one going up. Similar on this side, here is going up as it comes from the left side and down as it comes from the right side, but same idea. Just imagine there's arrows on these things like there would be, and that's the idea. Those are opposite arrows for opposite infinities for the behavior at an asymptote. However, the other possibility is that when you approach that asymptote from both sides, it actually goes in the same direction, meaning, again, here is the asymptote at x equals c, and as we approach from either the left or the right, it's going both upward, right, to positive infinity, or in this case, they're both going downward towards negative infinity. And so that's referred to as the asymptote having a same infinity behavior. And so the nice thing, the consistent or convenient thing about this is, recall, for x-intercepts, when we talked about odd multiplicity, having it go through the x-axis, think about what that means. We drew pictures of it before. To go through the x-axis means your graph went from above it to below it, or below it to above it. And by it, I mean the x-axis. So for odd multiplicities, the sign of your function went from positive to negative or from negative to positive. It changed, right? To go through the x-axis means your y values went from positives to negatives or from negatives to positives. So it changed the sign. Well, that idea is consistent with the asymptote multiplicity. Same idea. If we're looking at the zeros or the factors that give us these asymptotes, if there's an odd number of factors, which includes one, a single factor, then that odd multiplicity tells you the infinities are going to be different. They're going to be opposite, right? Which you can think of just the same way. You can think of it as changing sign. It's negative on this side and it's positive on this side, or positive on this side and negative on this side. So the idea of the opposite infinities is really kind of consistent or similar to this idea of going through the axis for intercepts. You're going from a positive to a negative or a negative to a positive. And so similarly with the even multiplicity, bouncing off. Remember the bouncing off habit was you've got your x-axis and the graph comes and bounces off of it, whether it's above or below. And so either way, if you've got a graph that's coming down from positive, being above the x-axis, hits that point and bounces off, it's still positive. It's still above the x-axis. So you're going from positive and then still remaining positive, or negative and remaining negative. And notice that will be similar to these behaviors for an even multiplicity. So if we get an asymptote that comes from a factor that has an even exponent, right? We have that factor squared or fourth powered or whatever in our denominator, even multiplicity, then it's going to have that same behavior on both sides, same infinity positive or negative. Now to figure that out, we will have to be using other information as we're drawing the graphs. We don't get to know which of these four pictures it is just by looking at the multiplicity. It's information we'll use when we're getting ready to graph, which we will actually be doing here in a moment.